The first hyperbolic function is the sine hyperbolic function. It is defined as follow. So for x we assign sine hyperbolic x is defined by the exponential function x applied at x minus exponential applied at minus x over 2. So let's study this function completely and graph it. So the domain, it is clear that my function is defined everywhere. What about the yes, we can compare also. We see that there is something about the parity. So what about sine minus x? So it's a minus x minus a plus x. So x over 2. So it's minus sine hyperbolic of x. So this is, so it's an odd function. The function is odd. What else now? What about the derivative? The derivative of sine hyperbolic x. So if you derive, you will get half of exponential x plus a minus x. So it's a positive function, strictly positive. That is, my function is increasing function. Okay, so the monotony sign is increasing. What about a second derivative to study the concavity? Sine hyperbolic x, so it will be half a exponential minus a minus x. So to study the sign, let's just rewrite the expression differently. So it's 1 over ax, which I can write as half of ax and a 2x minus 1. So this quantity is positive, okay, if x is positive, is greater than, yes, is positive. So convex. So the second, so we have, yes, so as conclusion here, so it's convex if x is positive, okay, and concave if x is negative. Okay, great. Almost there. We need now, yes, let's do as usual our small table. Okay, let's maybe change color here. So if I graph my small table, so my function is defined everywhere. Sine hyperbolic x, okay, it is an increasing function. 0 is an inflection point. It changes convexity. At 0 the value is 0. Now I need then the behavior, limit behaviors. So what about the limit? So if you compute limit sine hyperbolic x as x approaches plus infinity, so look at the formula here. The exponential x will approach plus infinity, but this quantity approaches 0, so everything will approach plus infinity. So I will have here plus infinity. For at minus infinity, I will have here the first term approaches 0 and the second approach plus infinity, with minus will be minus infinity. So I will have those two limit behaviors. So still, if I try to graph my function, still I know it will be hard to have accurate graph, since I have large values at plus infinity when x approaches plus infinity minus, but I don't know which side exactly. I can take as usual for some points, but for this particular function we have the following information. So we can remark that if you take the difference, if we compare sine hyperbolic with the exponential x over 2, and the limit as x approaches plus infinity, okay, we see that plus infinity, so we said so it will be, the difference will give me the remaining term, this one, but as x approaches plus infinity will be 0. So sine hyperbolic is close to the exponential function, okay, and it is under this under, yes, so this is at plus infinity, it's above, it's negative, yes, it is less than the is above below this function. Okay, so let's try and similarly we have the following comparison: sine hyperbolic x minus exponential minus x over 2 as x approaches this time. If you compute the difference, so you will get the remaining term. So the interesting limit is at minus infinity, okay, which gives us 0. Again, my curve is close to the other curve. So now let's graph. We can graph now our function. So maybe I can use another color here. Yes, let's use the red one. Here it is. So I can graph my function here. So x and y. We said that our function is an odd function, so it's enough to graph it on one side here from 0 plus infinity, then deduce by symmetry about the origin. Yes, let's graph those two curves, exponential x over 2, so it's here is 1, here is 1 over 2, so just it is a translation, or it's not a shift, no, it's stretched by 1 over 2, factor of 1 over 2, so still we will have something that looks like the exponential function. So let's say this one ax. The other one, a simple study, we can study it and we get the following graph. Okay, so this is minus half a minus x. Great. Now my function at 0 takes the value 0, so let's choose a color, green color. So it takes 0, then increases going to plus infinity, remains under this curve, and when x is very large, the difference between the two y's will be 0, approaches 0. So I will have something like that. And my shape is convex for x positive, so I will have something like that. So no, it's not good. I didn't do it well. Maybe I should even remove this one. So I will have points like that close to this curve. Okay, like that. And the other by symmetry, okay, and we know also we have it's close to this one and it is concave, so we will have this shape. So this is the sine hyperbolic function, the graph sine hyperbolic function. Now the second function, since my function here is increasing, is 1 to 1, then since it is 1 to 1, so it has an inverse function that we denote as usual, so sine hyperbolic minus 1 x. Okay, so this is minus 1. Okay, so let's see how we can so I will just give you the formula and we will try to justify why is it like that. Okay, so sine hyperbolic, we show that it is equal to, it has the formula ln x plus square root of x2 minus 1. Okay, okay, so one remark first, the derivative. So if you derive the sine hyperbolic minus 1x, its derivative gives you the function 1 over square root of 1 plus x2, which then tell us that the antiderivative of this function will be the sine hyperbolic minus inverse sine hyperbolic inverse plus a constant, so a new antiderivative. Okay, now how we will we showed this point. So proof of a star. So let's prove the proof of the equality. Okay, so let's set y sine hyperbolic x. So x, it is equivalent to say that x is sine hyperbolic of x, of y. Sine hyperbolic of y, we know the formula, so by definition it's 1 over 2 ay minus a minus y, okay, which we can write, so from which we deduce that 2x equal ay minus 1 over ay, which gives us a2y minus 2x ay, okay, and minus 1 equals 0. Okay, and here I will look at my function here, you setting the change of variable is okay with t positive. I have an equation of second degree 2xt minus 1 equals 0, whose delta, if you compute the delta of this equation, its delta is of 4x2 minus plus 4, you see, which is positive strictly. So we have two roots. So t1 equal 2x plus square root 4x2 plus 4 over 2. Yes, and the second one, t2, is 2x minus square root 4x2 plus 4 over 2, but this one is negative, so it's not the good one. So this is the good one. So as conclusion, ey is equal to, simplifying by 2, you will have x plus square root of x2 plus 2 plus, yes, plus 1, from which we deduce y equal ln of x plus square root of x2 plus 1. So I wanted to give you yes, this kind of reasoning that we will have, we can meet elsewhere. Okay, it's good to see it first time. So here is how we introduce sine hyperbolic function using the exponential function, and its inverse, sine hyperbolic minus 1. Okay, there are other families of hyperbolic functions. The second one is the cosine function. Okay, the cosine function here. So I put here similar argument techniques of calculation and studying. We define exponential, the cosine hyperbolic, as the sum of this exponential. It's an even function. Okay, so we have an even function here this time. It's an even function, and its derivative, if you derive, you get sine hyperbolic. So the antiderivative of sine hyperbolic is cosine hyperbolic. Okay. To study the convexity, we see our function is always convex. So also we have this comparison with these two functions, and we get the shape, the global shape of the cosine hyperbolic function. Okay. So as you see from the graph, my cosine hyperbolic cannot be a one-to-one function, but we will reduce the domain, the study of this function, to 0 plus infinity, which gives us an inverse function cosine hyperbolic minus 1. Okay, and we show, as we showed for the inverse sine hyperbolic, that it has a formula like this one. The derivative gives us this fraction with the ratio, with the square root, and then we have a new antiderivative. Okay, and the third category is function hyperbolic, is tangent hyperbolic function, sine hyperbolic over cosine hyperbolic. The derivative is positive, so my function is increasing function, so it has an inverse also. Its inverse, we show that it has this formula. So you don't have to memorize all this formula, you can always refer to a book or sheet to use the formula you need. Okay, in particularly the derivative is 1 over 1 minus x2, and so we have new also antiderivative. The derivative of this function is the tangent hyperbolic minus the reciprocal tangent hyperbolic. We remark an analogy with trigonometric functions. Like here we have a difference of the square of the cosine square hyperbolic, and the sine is 1. The sum of sine hyperbolic of a sum is something like that, looks like for sine with sine, similar to cosine. There is similarity with cosine trigonometric functions. So this is what, yes, so you have now 6 new functions to add to your library of functions, the hyperbolic functions.